Welcome to my presentation. In this presentation, we shall try to find the inverse of a matrix. Let's take an example here. And in this example, let's say we have elements of this matrix as 1, 4, -1, -3. This time we are going to use Gauss-Jordan elimination method. We're going to solve this by, let me write this here, Gauss-Jordan elimination method. And according to Gauss-Jordan elimination method, this is what we do. We partition the given matrix with an identity matrix. We'll call that as step number 1. The given matrix is 1, 4, -1, and -3. We partition it with a dotted line, and then on the right hand side of the partition we will have the identity matrix. Since the given matrix is a 2 by 2 matrix, the identity matrix will also be a 2 by 2 matrix, and this time the elements of the identity matrix would be 1, 0, 0, 1. And one of the conditions of an identity matrix is that the major diagonal of that identity matrix should be, the element should be 1, and then the rest of the elements should be 0, and that is satisfied there. So for our understanding's sake, this is the matrix A, and this is the identity matrix I. And according to Gauss-Jordan elimination method, when we perform the row operations, I'm going to just briefly explain the procedure here, and then we will complete this problem in just a minute. So the procedure for this is, when we perform the row operations, it will so happen we want to arrive at this type of a matrix where the left hand side of the partition is going to be 1, 0, 0, 1, and then on the right hand side of the partition, because of the row operations, we are going to get some values here, and I'll call it as A, B, C, and D. And when we do this by performing the row operations, we have achieved the inverse of this matrix. On the left hand side, this will be the identity matrix, and this will be the inverse of the given matrix, and that is what we are looking for. That is the advantage of using Gauss-Jordan elimination method. Okay, so that is the concept we want to follow, and we will follow that concept to solve this example problem. So let's get started. In step 2, we're going to say we want to have 1 at the location first row first column. We have that. We want this location here, let me write that with red, we want this location to be 0 according to our final matrix. I'll put it by a different color here, so that way you see this is what we want. Let me get this one. This is the matrix we finally want to achieve, which is in the green box, and therefore we will come to that we will arrive at that in just a few minutes by following these different steps. So first things first, we want this -1 to go to become 0, and to achieve that we're going to do the row operation. To achieve that, we're going to say the new R2 is going to be equal to, we can achieve that by just adding row 1 plus row 2, isn't it? So if you look at that, 1 minus 1 will be 0, and then 4 minus 3 will be equal to 1, and then in the partition side of it, 1 plus 0 will be 1, and then 0 plus 1 will be 1. I just wrote the second row. The first row will be the same. We did not change anything. 1, 4, 1, 0. we'll keep going. So we got one thing out of our way. So we wanted to achieve let's draw this line here. We have ones along the major diagonal. We wanted a 0 here, we got that. We want a 0 in this location. So to achieve that, we're going to perform the row operations again. We'll call that as another step, step number 3. And this time, we want to perform the row operation on row 1. The new R1 is going to be equal to existing R1 minus 4 times R2, isn't it? 4 times R2. So how does that look? 1 minus 4 times 0 will be 1, and then 4 minus 4 times 1 will be 0, and then on the other side of the partition, 1 minus 4 times 1 will be 1 minus 4, that will be equal to negative 3, and then on the last on the next element will be 0 minus 4 times 1, that will be negative 4, like that. And then we will come back and then write the second row in here, which is 0, 1, 1 and 1, like that. Now when we look at the matrix on the left hand side of the partition, we have ones along the major diagonal, we have zeros elsewhere, and therefore this is our identity matrix, and the matrix which we have on the right hand side of the partition, that is our inverse of the matrix. That is the inverse of the matrix. So therefore we have successfully achieved the inverse of the matrix by using this Gauss-Jordan elimination method. These are very powerful methods, and calculators, the graphing calculators and some of the scientific calculators use this method to be able to do the inverse of these matrices. So in my next presentation, we shall look at some more examples to see how we can perform the inverse of a given matrix.